And welcome everybody to the Daily Space Weather. Today we've got way too many things to talk about, no screwing around. So let's get into it suddenly. So the first thing we're doing here is looking at the sun in 193 angstroms. And it's pretty epic stuff going on. Geomagnetic unrest, as well as coronal mass ejections, one of which is somewhat partially headed sort of in a earthly-ish sort of a direction type of a thing, kind of a scenario type thing going on. We'll tell you more about that momentarily. We'll also tell you about locking the door. Don't forget to lock the door in order to protect the outside from you. So let's get back to some more data here. We're going to go out and look at the view from Lagrange point 5. So stereo A located at Lagrange point 5. Let's see what the last day or so looks like from out there. And we see some coronal mass ejections headed sort of in an earthly vicinity. One of these looks like it may be a glancing blow. So no direct strikes from these. The Earth would be out in this direction, folks. For all you new viewers, the Earth would be out in that direction. And so that one coronal mass ejection you can see there is certainly in the earthly vicinity, just not directly earthly facing. It's sort of mainly directed in between stereo A and Earth. So here's a view from the LASCO C2. This is located at Lagrangian point 1. Right there, about 1 million miles toward the sun. You can also see Venus swinging into view there. And so you see most of that coronal mass ejection expected to miss to the east. Here's a zoomed out view of essentially the same thing. The LASCO C3. And this white circle here, that is the solar chromosphere, the outline of the chromosphere. And once again, we'll just show you stereo A again just to close out this segment. Here's stereo A. And we did a video about this yesterday once it was fully propagated. There is actually, again, Lagrange point 5 is where that is. And this is actually still an ongoing event, folks. There still is some ejecta that has not exited the corona yet. So here's another image of the sun from SDO. And this orbit's much closer to the Earth. This is the 171 angstroms and colorized magnetogram composite. And this active region up here is indeed not a sunspot. It's not name-worthy yet. It did have umbre, and now they've gone. Sunspot 2810, which is this active region here, is still a sunspot, still alpha class, still degrading. Here is a magnetogram of the northern hemisphere. And we're going to show you a close-up of that rising active region, which was a sunspot earlier when I got up today and is no longer a sunspot. So we'll have to keep an eye on that to see if it ends up getting a name or not. In other words, to see whether or not it has umbre more than 12 hours. And there's a great view, a great animation of that rising active region. It's pretty magnetically coherent there. So don't be surprised to see that get a name after all. Here's a full disk view. Another SDO full disk view here, 304 angstroms rather. And you may see a bunch of filamentary activity, mainly on the eastern hemisphere, which would be your screen left. And we can see filamentary activity going on up here, as well as all around here, sort of on the eastern limb, as well as some filaments still suspended out here. So the likelihood of additional coronal mass ejections is near 100%. And we'll be keeping you posted on that later throughout the day today if we see any more releases happen. As the timeliness of solar activity has been quite cooperative with our channel recently. So, next, here's a diagram of the solar system to help orient you, the viewer. There's where things will be in a week, very close to a full moon 1 week from now, which means we're in a gibbous waxing. Are you enjoying your spring so far? We're less than a day in when we did this video. And thanks to everybody who viewed yesterday's spring equinox video. It was quite an interesting daily space weather video. If you didn't check that out, there are playlists and so on. Check out our other content as well. Here's a star chart. This one is from in-the-sky.org. And I've drawn in the ecliptic here. This is the yellow line. That's the path that the sun will take across the sky throughout the day today, passing through Sagittarius and Scorpius and Libra and Virgo and Leo. I don't know if you care. As astronomy begins to look more like astrology in many real and many imagined senses. So the 10.7 centimeter radial flux has come back up to 80, folks. And yeah, radial flux back to 80 now. There's the 1 year chart of that. It's that black line there that my pointer is pointing to. And the red line underneath my pointer there, that's the sunspot number. Radial flux back up to 80, despite that graph not being updated. So here you can see the glancing blow that NOAA forecasted here based on the coronal mass ejection that we reported on yesterday. And you can see this little increase in the plasma density is nothing to even really create much of a blip. Although we're not expecting to see a coronal hole wind stream at that time, so we may see a little uptick in the solar wind density. Who knows? We'll cover it when it happens, if it happens. And we can see there is additional geomagnetic storm conditions forecasted by NOAA today. So you can see geomagnetic storm KP5 G1 class geomagnetic storm forecasted for the end of the day and early day tomorrow, according to NOAA. No arguments there. It's pretty hard to figure out when these things will strike. Speaking of strikes, volcanoes have gone on strike. It's a downtick in volcanic activity. Although Abico still erupting, flight level 100 above the caldera at Abico. Please don't pole vault the caldera, and don't pole vault the caldera of Cleveland volcano either, located in the Aleutian Island chain. Cleveland erupted last June with some significant ash plumes. It's had its alert level raised to yellow. Pacaya and Fuego, both erupting in Guatemala in an explosive fashion, each producing 14,000-foot plumes of volcanic ash. Sabancaya also erupting. Intermittent pulses of volcanic ash from Sabancaya are a reminder to, once again, remember not to pole vault the caldera. I'd like to welcome all of our viewers to the Neo-Renaissance. If you've checked out smAsho.com, we're alt-tech. Are you on other alt-tech? Well, we are. We're certainly all over social media. You can find the links at our homepage, smAsho.com. Today's featured product is the smAsho Price My First Pandemic shirt. So let me just go back a little bit here. There you go. smAsho Price My First Pandemic. Put a mask on the whole planet, folks, then you'll be totally safe. You'll be safe and locked down and vaccinated forever and ever and ever and ever and ever and ever and ever, forever and ever and ever and ever. So that's today's featured product. If you want to check it out, you can find a link at smAsho.com. That's at the smAsho store. And yeah, smAsho Price My First Pandemic. And this was actually the first piece of merch that we made. We're only offering it in black and white right now because it seems like a black and white issue to me about the infantile and pathetic response of mankind to the coronavirus. Where have all the influenza gone? All right, let's talk about some earthquakes here. And shout out to Mary Wright. Thanks for informing us of this 7.0 magnitude quake. We did report on this yesterday during our equinox live stream. So we always stream at the moment of the solstices and equinoxes on the channel. Those are always YouTube live stream exclusives. In any case, largest of the past 24, since we're going so early today, is from about 9 o'clock Universal Time, 9:09 Universal Time yesterday, this 7.0 at Japan. And we talked all about the tsunami warnings and so on. 4.4 magnitude deep quake strikes western South America there at Peru over the past 24 hours. Looks like we see another Chinese quake, another cheap Chinese quake. We're glad we're able to make people laugh a bit while talking about very serious things. Are you able to remain stoic in horrifyingly dangerous situations? Well, I certainly am. I'm able to shoot a foul shot when people are screaming in my face. In any case, I'm also a good bowler, by the way. If you know anybody who needs to house somebody in bowling, just call me in. I'm a bowling mercenary, folks. There's a deep quake near Saipan. It's a 5.2 magnitude at 177 kilometers below the surface of Earth. Below sea level, folks. Here's another deep quake at Timor-Leste. So a few deep quakes kicking off here. 1.7 magnitude over the past 24 hours. Again, we talked about it yesterday. If you want to see the tsunami warnings associated with it, watch yesterday's Daily Space Weather video. You can find it at youtube.com/smashomash/playlists. And we've got a whole series of playlists there. No major solar flares over the past 3 days, but we see 1, 2, at least 3, possibly even 4 B-class flares. Nothing to really write home about. And I would remind our viewers once again that we regularly see coronal mass ejections with no solar flares. And without getting further into that, here's the proton flux, which we don't see any spikes in, as none of the ejecta have struck. Another measurement by the GOES 16 is the GOES magnetometer. There's the past 3 days of GOES magnetometer readings, and you can see these spiky sawtooth readings here. That's all throughout the geomagnetic storm conditions, as there is a bunch of plasma in between Sun and Earth right now, in the form of that high-speed coronal hole wind stream, which affects the magnetometer readings. You can expect to see continued spikiness, continued sawtooth-type patterns in the GOES magnetometers until the current coronal hole wind stream subsides, and I think it may subside a little bit earlier than NOAA has forecasted. I would remind you that NOAA is still forecasting geomagnetic storms into early tomorrow morning Universal Time. Next, let's take a look at the heliospheric current sheet. Yes, the current sheet. And you can see the South Pole-oriented current sheet is the most prevalent one, at least at the Earth's latitude. And the Earth will solidly remain in the South Pole current sheet. Keep in mind the data is an hour and 26 minutes old and can change with basically no warning. Here's another view of the same thing. This also shows you the sun's B field because it's oriented from a line of sight perspective. Large coronal hole there, that red blob in the south, is what's providing the current geomagnetic storm conditions, geomagnetic unrest conditions, etc., through primarily a stream of high-speed protons. Solar protons, folks, hydrogen nuclei, blasting through space at like over 1 million miles per hour, around 600 kilometers per second, actually. And there's a second South Pole-oriented coronal hole rotating in. We'll see if that retains coherence. by doing videos like this one on the daily. Next, I would note all the filaments that the filament detected filaments plot here is showing. And the reason you see those flashing is because some have released and some are about to release. So that's just the way it is. Some filaments will never release. That's just the way it is. Anyway, sunspot 2810 is still alpha class, and we see no other sunspots on the plot. No surprise there. Here's the geomagnetic storm conditions, and you can see the coronal hole wind stream is slowly subsiding here. I think I forecasted this to last about 36 hours when it first hit, and the timing has just been all too perfect. In the past year or so, the sun has been cooperating smashingly, perhaps even mashingly, with the channel. Were you watching back then? If you're a new viewer, don't forget to press like and subscribe. Don't forget to press the notification bell and share with your friends and foes on social media. Here's the real-time solar wind. And we have a little bit on the 24-hour chart here. I just want to revisit this. We saw the BTBZ get pretty wild at the beginning of this coronal hole wind stream. The graph has been shrunken back down here to 20 nanotesla, really a 40 nanotesla range here. BTBZ looking a lot more normal now. And the BT is the total field, and the BZ is the extent to which one of the polar fields contributes. So if you see a BZ of 0, you have an equal contribution of both solar polar fields. If you see a BZ of, say, -6, you've got more south solar polar field contribution to the BT, the total field. Know the distinction between poloidal and toroidal fields, folks. It's pretty serious stuff. Next, looking at the density, which is down to about 7.5. 7.1 protons per cubic centimeter. Current solar wind speed slowly tapering down over the past 18 hours to 560 kilometers per second. The highs that we saw there made it up to about 670 kilometers per second. I won't translate that into miles per hour. I believe it's over 1 million. It's fast. Next, looking at geospace magnetosphere movies, we'll show each one of these here. First, the velocity, it's 4 hours of data. And it's a perfect time to take a sip of your coffee. Let us know what's in your coffee. I'm drinking organic Ethiopian with some cayenne pepper and some cocoa powder, which is why you hear me stirring it. That's that clinking sound. Anyway, there's 4 hours of velocity at the magnetosphere level. Here's the density. Keep in mind the density shows you high density in dark blue, low density in white. Again, 4 hours of data on each of these 3 geospace magnetosphere movies. Lastly, we'll show the pressure. And that density was in protons per cubic centimeter. This is in nanopascals. Everything looking fairly as you would expect it. Keep in mind, this is all a model based on the space weather modeling framework, which uses, shall we say, a lot of data points. And we'll bring that back to where it refreshed, as it's not particularly poignant, but we've shown the 4 hours of data. Next, we'll look at ground magnetic perturbations. First, the polar view. And we've got some aurora photos to show you here momentarily. So there's the polar view of ground geomagnetic perturbations here. Geospace delta B, in other words, changes in the Earth's B field, folks. We actually cited some anomalies yesterday over the Philippines. If you follow us on Twitter, you may already realize that. If you don't follow us on Twitter, well, you're not getting the full story. We use Twitter for all kinds of different resources, such as writing our content. And we've got a whopping 128 followers or something like that on Twitter. Anyway, here's 4 hours of ground magnetic perturbations. And we see some coming out of the oceans here. The one we showed yesterday from the Philippines, over the Philippines, was just an anomalous little magnetic pulse. And we show this one daily as well, since we are currently in a geomagnetic excursion. Maybe we'll make a video about that later. Next, looking at the induction into the U.S. power grid. And you can look this up yourself. It'll give you some indication of where you're most likely to see a power outage happen, especially during major geomagnetic storms. This isn't a major geomagnetic storm. We'll probably have this cut from tomorrow's coverage. Here's the Aurora forecast, and we saw some significant aurorae. And thanks to Michael DeWitt, shout out to Michael DeWitt, expatriate who has moved to Alberta, Canada, and become a baker. Sounds pretty cool. We're waiting for our shipment of sourdough, Mr. DeWitt. Anyway, there's the Aurora forecast, and we've got some auroral photographs. This video, by the way, was streamed live to Twitch. It's twitch.tv/smAsho. It's a fantastic mobile streaming platform. And if you're wondering if I'm a gamer, the answer is yes. I play one game, folks. One. Wolfenstein Enemy Territory. If you've never checked it out, it's free. Check it out. It's free open source software. Wolfenstein Enemy Territory. You can find me on the FA Fearless Assassin servers, which are an American server which feature some of the best enemy territory players in the world. If you don't follow me on Instagram, you won't see the other photo. And I think what I'm seeing here is actually a vertical pillar. So I think that's one of these vertical pillars here, folks. Not exactly sure. And the other photo is better. Thanks again, Mr. DeWitt, for the photos. We've hosted those on Instagram. You can also find links to our Discord channel. If you haven't checked out our Discord channel, it's linked at smashomash.com. And Discord channels do require you to have an invite. Also, I would invite everybody to check out our playlists. youtube.com/smashomash/playlists. You may see some stuff there you were not aware that we're even doing. Maybe the terms defined playlist. And we may make another video today about coronal holes. We'll see what happens. We've also updated the main homepage here on YouTube to have smashomash.org presents The Sun Part 3, which is a spectacular series of views of the sun and featuring Beethoven's Moonlight Sonata. So perhaps check that out if you haven't. It's right on the homepage at youtube.com/smashomash. And don't forget to press like and subscribe. Thanks to our BitChute viewers. Have you seen our most viewed video on BitChute? It's not even available on YouTube anymore. BitChute.com/smashomash. Look for another video coming today as well about the COVID Chronicles. It'll be the third installment of that. That's also a playlist. And let's do a cosmology segment. Like I said, folks, lots of stuff to cover today. So today's cosmology segment will feature a few different things. First of all, let's talk about our mission. You can find the rest of our mission at smashomash.com/forum/mission. smashomash.com/forum/mission. You can link to that on the homepage as well. Number 5, to publish scientific papers in a multidisciplinary manner, including but not limited to science such as spectroscopy. Notice how that's the first thing on the list, folks. Spectroscopy. Also chemistry, astrophysics, health, wellness, longevity, cosmology, biology, magnetohydrodynamics, geology, etc. Why am I stressing the word spectroscopy? Well, because some people seem to agree. Now let's talk about the way that gravitational waves affect dark matter. Gravitational waves are waves that are created through gravity, and we're able to detect them using LIGO all the way from Earth, because when neutron stars and black holes merge with each other and other stars orbit each other, like you're seeing here, they create ripples through the space-time reality, and then gravity gets warped, and we can test them using laser interferometry. Just kidding, folks. There's a new Sky Scholar video, which is entitled The Most Important Tool in Astronomy, Analysis of Spectroscopic Lines. Yes. Yes, folks, it's true. The most important tool in astronomy, analysis of spectroscopic lines. Now, I would tend to agree. Now, I used to think radio astronomy was boring, but people like astronomy professors in the mid-90s informed me that radio astronomy is the future of astronomy and it's far from boring. Well, it turns out that it's all too true. I kind of believed them back then, I just didn't understand the physics of why. Well, I currently understand the physics of why, and so does Robitaille. So here is a little tiny clip of a video I haven't even watched yet because we've been so busy with, well, things that you may already know about if you watch our other videos. But in any case, here's a tiny blurb from Sky Scholar, aka Pierre-Marie Robitaille, regarding analysis of spectroscopic lines.
Note that now we are talking about the broadening of the spectral line, not its shift. Doppler line broadening is caused by random thermal motions of atoms.
And I'll just leave it there to play you a teaser so that you watch the video. We'll share this as a community post later today. Make sure you subscribe to Sky Scholar and watch all of the videos. And next we're going to go into a random number. So random number between 1 and 1031 will coincide with some object over at the Neil Gorell Swift-Bat X-ray Observatory. Today's object is entry 358. And what might 358 be, you ask? Well, you don't have to ask because I'll ask. 358 is 4C01.28, a quasar, which will probably look like a single point of light. First, let's look at the X-ray emission spectra, the transient X-ray outbursts from this quasar, and there it is. By the way, if you have a galaxy, let's say you have a galaxy that's looking kind of warped like this, you're looking at it not directly down the polar field, right? You're looking at it from an angle. When you're looking at a galaxy from an angle, there's a polar jet that comes out of the galaxy's core like this, in many cases perpendicular to the disk of the galaxy. If you're looking at the galaxy from this sort of a perspective, the galaxy looks very bright. That is what we call a quasar or perhaps a blazar. If you're looking at it sort of from this orientation, it'll be what we would call an active galactic nucleus. And if you're looking at a galaxy and it just kind of looks like this, with a little bulge in the middle sometimes, that's most likely going to be a radio galaxy. And it all has to do with perspective. This one is a quasar, probably looks like a single point of light. Let's see if my forecast comes true. Anyway, there are the X-ray transients. We actually saw some major transients out of it, and this one is completely off of the scale. That one might actually warrant some further study there, as it's almost all the way up to 0.3, where this scale only goes to 0.03. This outburst right here is well off of the historic chart, as you can clearly see there. Let's see what else is going on with 4C01.28. It'll look like a single point of light on Aladdin. And there you can see that quasar. And that's because, once again, you're looking directly down the polar field, which makes these galaxies look very bright and obscures them because of the nature of the material being emitted from its core. So here it is on the 2 mass. Let's take a look at it on blue light. There it is in blue light. It's looking pretty symmetrical there. An indication that we're probably quite centered on the polar field of that. Here it is on Chandra. You can see it's a very, very bright X-ray source. And perhaps this is giving us some insight into the orientation of its galactic disk. As you can see, this series of line-like data points. See if it shows up on XMM Newton. And there it is on XMM Newton. Quasar 4C01.28. Today's recently active quasar. And that's today's cosmology segment. Next, looking at electrons. we're coming back to Earth now, folks. And these are electrons measured at the ionosphere layer by the GOES-16. There's a 3-day chart of the GOES-16 electron flux. And it looks like it may have peaked out here. The forecast by NOAA is for an increase in the electron flux, and not so sure about that. I would have to disagree with this forecast, thinking tomorrow will be more like here as opposed to up there. Notice how today's forecast was nailed once again for the relativistic electrons. And what we're seeing here, what we're looking at here for you new viewers, is the green boxes are the forecast and the yellow diamonds are not Lucky Charms, marshmallows. Those are the observation. Here's the total electron content to about 12,500 miles of altitude. This is the inner Van Allen belt, essentially, folks, and this is the electron field through which a GPS satellite would need to communicate with your handset. If you're around the equator at noon, expect to see GPS errors. And we see some significant anomalies here. A sudden reduction in the electron flux right here. Pretty exhausted electron flux right at that moment. Around, let's see, around 1630 Universal Time here, just to the northeast of the South Atlantic anomaly, which is somewhere around here. And keep in mind, folks, we also have a second anomaly now. The South Atlantic anomaly has split, and we've got a South African anomaly as well. The two weakest spots in the Earth's magnetosphere. And that does indeed affect where the electrons are located. We won't get into a big plasma physics dissertation here. That's the total electron content. And again, this is showing the air column from a GPS satellite down to your handset, about 12,500 miles of altitude, is where those geosynchronous satellites are located. Geosynchronous GPS satellites. Ionosphere looking anomalous today as well. We see some major charge-ups of the ionosphere happening. I believe they're over the central Atlantic Ocean, but we'll just let this play through here. Give this one a minute. We've updated this to a higher temporal resolution here. It's now 15 minutes per second at a full day of data. So we're going to start looking a little bit harder at the ionosphere. Sudden charge down there. You see those red blobs making it into an F layer as opposed to an F2 or F3 or F14 layer. And what this is showing you, folks, is the vibrational frequency of the ions in the ionosphere. The data is courtesy of Australian Government Bureau Meteorology. And okay, those anomalous charge-ups there are over the Indian Ocean. So you see that right there, those big blobs forming. That is a very anomalous charge-up of the ionosphere. So happening right around India here, the equatorial portion of the Indian Ocean. Anyway, here's the latest image, which came through at 1645 Universal Time. That's looking a little bit whoa. Why is the latest image? What is up with that? I'm going to reload this whole thing. All right, I've pressed reload and it didn't reload. I'll press reload again. Let's see what happens. Anyway, we caught some interesting anomalies there. I've never seen that sort of a charge up, especially on both sides of the equator. It is during a geomagnetic storm as well, folks. So that's at least geomagnetic unrest conditions were occurring at that moment. In fact, let's go back and take a look here. That would have been just around this moment. So there would have been a geomagnetic storm condition at the time that we saw that anomalous 14 megahertz charge up blob over the Indian Ocean. And I look at it daily. I have leeway to say that it looks anomalously. So here is, let's see if it reloaded here. All right, here we're moving into today now. There's the 21st showing. And we'll let this play through here as it's a little more data than we've previously been showing. Keep in mind the resolution is only 1 megahertz. Some charge ups around the South African anomaly there. The area over the Indian Ocean. Once again, looking a little, check it out, large charge up blobs there. Both sides of the equator. Oh, we're back to yesterday again. Anyway, here's the latest image. Latest image coming through at... Could we have today, please? Apparently not. I don't know what's going on with the site. It's showing us yesterday's data. Anyway, here's the diagram that we show daily to give people an idea of what we were looking at. And what that was the ionosphere right about here, around 300 kilometers of altitude, folks, just above, about 70 miles above where the International Space Station is at about 230. Wait, I think that's miles. International Space Station, 230 miles. Anyway, let's get into the realm of meteorology here. And looking at the jet streams of the eastern world has me saying, oh my God. The jet stream is incoherent in the southern hemisphere. Check this out. An incoherent jet stream area there. It's sort of tripled up and it's sort of incoherent. Like a lot of people I hear talking about meteorology who know nothing about the physics, but decide to report on it anyway. It's hilarious. And otherwise not too weird in the eastern world there. A little bit of meridional jet stream flow right here. And here is the jet stream scenario of the western world, which is weird. I can see already that it's strange. We've got a huge kink here. A low pressure jet stream ridge, or a low pressure jet stream trough, I should say. All the way from the northern Rockies into the North Pacific. Also a huge divergence of the jet stream there over the Great Lakes region. And some extreme kinks in the jet stream here over southern South America. Blowing backwards right here. Ask a pilot, he'll agree. And let's talk about climate for a quick moment. Sea ice levels in the north, the Arctic Circle, aren't that high. They're at the very bottom of the 20-year range here. 10-year range, rather. That black line is the current situation. Although the Arctic is far from ice-free. Let's look at another data point. How about snow? There's the current real-time snow map, which has moved us to someplace else because reasons. Here's the real-time snow map. What the heck? All right. And here is the snow mass. So you can find this yourself at Global Cryosphere Watch. Global Cryosphere Watch snow mass balance. And notice how it's 2 standard deviations above normal, where it just got at the end of the season and made it to 2 standard deviations above normal. That's the red line there, folks. And the blue shaded in region here, that's 1 standard deviation above normal snowfall for the 30-year average. So check it out. About 2 standard deviations above normal. That's the 4th winter in a row. 2017 to 2018, 2018 to 2019, 2019 to 2020, and 2020 to 2021 each had 2 standard deviations above normal snowfall featured on this graph. So snow mass balance, you're talking about the amount of snow in terms of its weight, and you're talking about not including the mountainous regions to get that data. So let's go back to the real-time snow map here. I don't know why Windy keeps reverting our view, but there is the real-time snow map. And it's looking pretty snowy in the northern hemisphere. What do you think? Expect flooding to ensue as a result of things like that. Look how much ridiculous amount of snow. So it's the first day of spring, the first full day of spring today, folks. And we can clearly see areas here that have 55 inches of snow. Check out how much snow is in eastern California. 50 inches or so in a lot of those spots. It's going to be a long spring ski season. And there's going to be a lot of meltwater for all of you whitewater rafters. In any case, let's see if more snow's forecasted to fall. Here's the Euro forecast for snow depth into 12 noon tomorrow. I don't know what's changed. I got to move on. We don't want the video to be too long. And again, here's the, what is this, the Rutgers? Here's the Slutgers Global Snow Lab. And here's the NOAA. It doesn't look particularly hot. What do you think? Leave us a comment. Let us know if you think that looks hot. Apparently the planet's so hot that it's cold, folks. So you better reduce your CO2 footprint. It's very important. Carbon dioxide totally has anything to do with the climate. Carbon dioxide totally controls the climate, folks. Pardon my sarcasm. Next, blitzortung.org, real-time lightning map. I like it. Let's hope their lightningmaps.org server is back online soon. And notice the way these lines are starting to slant toward the north. Slant toward the north. We're going to hear all about how, oh no, Greenland is melting. Greenland is melting. It's coming. It's coming, folks. Next, looking at the cloud layer. And we see some anomalous features here. Check out these low clouds. They're flowing the opposite direction of the jet stream. An indication that they're at a low altitude. See them flowing in that direction? If you think those are chemtrails or ship tracks, I suggest you consult a psychiatrist. Or maybe take a physics class. Here's the water vapor map. And you can see the vast differences in the water vapor map versus the cloud layer. And check it out. We've got hot air. We've got hot air going into and coming out of Colorado. So much hot air coming out of Colorado. Check it out. Hot, dry, massive air. Very hot. Very hot and very loud. Sometimes very obnoxious, depending on who is supplying that particular hot air coming out of Colorado. Also a bunch of low clouds over the Gulf of Mexico here. And yes, low clouds are associated with cosmic ray flux. Here is the Doppler radar map. Some heavy rains there in South Carolina and eastern Georgia, as well as some heavy snow in central Wyoming and some scattered snow all over most of the Rockies in the U.S. Thanks to our patrons, the true source of funding for the content. Please consider becoming a patron if you'd like to see these videos continue to exist and be publicly free to view and so on. If you'd like to see these videos continue to exist on YouTube, please consider becoming a patron at patreon.com/smashamash. Thanks again to our patrons. And let us know if you have any requests. We will consider any reasonable ideas. So here's what's going on currently. This is what we saw during show prep, and I'll show you exactly what I was looking at. Here's the colorized magnetogram, and here is the intensitygram. So you can see sunspot 2810 right here. And non-sunspot, I thought it was going to be 2811, but the umbra has evaporated. So we've got one sunspot group, folks, and it's pretty weak. Sunspot 2810, it's been degrading, and we'll give you some more close-ups of that momentarily. First, let me hit refresh and see how these have changed in the past half hour or so. Let me just get them both on screen and get them lined up for you here. Again, we are streaming live. So once again, this active region here has no umbre, so that's no sunspot. And this region here is a sunspot. It's sunspot 2810. Looking steady since we did show prep. And here is a view of it in ionized carbon. Yes, ionized carbon, folks. This is 1700 angstroms, and it's one of the less common wavelengths that we use. And you can see the ionized carbon emanating out of that sunspot there. It's showing you bright yellow colors in ionized carbon. And here's the same region in 131 angstroms, one of the crowd favorites. Here it is in 94 angstroms. One of the SDO favorites, as it takes 10 images per minute instead of only 2. Give it a moment to initialize here. It is animated. And it looks like maybe some of those solar flares, those little B-class flares, did indeed come out of that new active region. We'll be keeping an eye on it to see if it develops any umbre, as well as watching the ongoing coronal mass ejection situation, which is unfolding still. And last but not least, a 171 angstroms view. Thanks for tuning in, folks. Remember, stare at the sun, attempt to understand the physics, don't drink it. If you do, don't drive. Welcome to the Neo Renaissance. Visit our links and support the channel. Again, if you'd like to see these videos continue to exist. Welcome to the Neo Renaissance, and may that solar wind be at your back.